think I have to rework how we go about creating new entities before I can get the hero back on the screen. Originally in the Lua, whenever we called this function create entity, it would call a Lua function that would create an entity object, which is a Lua table, and insert it into another table for the given ID that we are currently on. So we're going to need a global to indicate like the current entity ID. Then when we actually create an entity, we're simply going to be incrementing that value and then assigning some values to different locations. We could create structs to represent the entities, but I'm also thinking, this is a good opportunity to actually make things more component, like entity component oriented. So I want to try and implement this using components. One question is though, do I want to merge the current branch over into master? We've got this branch that we're currently on, that's Lua deconstruct. Right, we have merged the code over. What's next? When we go to create an entity, one of the components for the entity is a name, right? And this is kind of like, let's think of an example of how to do this. But minimum, you need a next entity ID, right? We create entity. We don't need to pass anything in here. Um, but if we don't store the entity somewhere, then like if we don't store the number for the entity somewhere, then we lose it forever. So at the very minimum, we're going to need some sort of array type structure to manage our entities. Um, we could use some sort of linked list, or we could just use like a basic array. So in the very beginning, everything here is going to be we would want it to be 1 or 0, or sorry, -1 or 0. I haven't decided yet. That should work. Before all this, because we're going to end up creating the hero like here. We go and knit the entity list here. And if we end up ever needing more entities than 1024 ints, which that's really not a lot of room. That's only 4 kilobytes. If we ever end up needing more than that, then we'll write stuff to grow the list, and we'll properly do error checks to make sure that we're not outside the bounds. We would also need a current number of entities in the list, right? So now we would want to Like when we go to create the first entity, the reason we do it this way instead of what the copilot was suggesting is that this isn't a hash table. This is a array. So we're gonna have to like store certain values, like possibly at a location that doesn't reflect the ID. So like even though in the beginning the IDs might be one thing, you know, later on if we end up deleting a lot of entities and then replacing them, it could very easily be that the location in the list is not, like the index is not equal to the ID all the time. So but at the very minimum this would get the entity into the list at an ID level. Now, if we wanted to associate a type of entity and a name, right, we're going to need some more things. Remember that we're going to attempt to do this kind of in a component style, like entity component. Actually, we're going to make this, we're going to make the name small right now, right? That's kind of big for, that would make like a very big, 1024 by 1024. That's like a whole megabyte. Do we really need that long of a name for every name? You'd probably get away with like 128. No, 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 no. Why is it like fake coming up with some fake ass shit like that? Default entity list size. Then down here, this is stupid. This should actually be, it should be using something like string copy or B0. Um, so there's that. Anytime we add like a new component, when we go to init, the entity list will also init the new component data structure. So, and actually, this would need to be a hash table at this point. I don't want to have to write a whole ass thing with a bunch of pointers and stuff if I can avoid it. Because, yeah, the entity list itself is just a list, but at this point, once we actually start getting into the components themselves, we need to be hashing, right? And actually, if we wanted the list size to grow at some point in the future, we would have to have this as a pointer. So let's start there. Okay, so we allocate the memory for the list. We mem set, and then we set list size to 0. So how are we going to store names? If we hash to a particular location in the names list and we need to chain, we're going to have some sort of structure to link the subsequent values. So at the minimum, we would have to store the ID and the pointer to the string that we're constructing. So we need something like type def. Oops. Type def struct. Entity name node, or just call it entity name, ID, and then a name like that. I don't expect us to have to chain very often. So maybe we can get away with like a minimum number of chains. Because if we hash to a location and we check the ID versus the ID of what we're trying to look up and it's not there, then we would check one slot over, right? And then if it's not there, we check one slot over. So that would have to be a double pointer. Oops. Default entity name chain size. Oh, that's too big. We said like 3, right? No. We're gonna mark here. Yeah. Okay, so far so good. So in the very beginning, we do this. That way every slot is 0. So when we first hash to a location, I don't think this is going to work. Oh, we would also have to do times default entity name chain size. So that might work though, because we have to scale the dimensionality. So like size of entity name is, a name pointer. That's just 1. Multiplied by entity list size gets us the full list. But then to add the extra dimension, we have to multiply it by the chain size. So when we go to create a new entity and we hash that location to see if there's anything there at the moment, if there is, then we check the next slot over. And then if there is, we check the next slot over. And then if there is, we're out of room and we can't insert a new entity. Otherwise, we just create a new entity and insert it at that location. So now when we go to create entity, type race X, Y, direction. Actually don't need these two anymore for the moment. Oh, why is it doing that? No, we don't need the malloc for name. We just need to string copy. No, they don't have a next. Oh yeah, it's entity names. There'll probably be a better way to write this. I'm just gonna get it working in the very bare minimum to start with. What's up, everybody? Hope you're all having a good day. Pretty soon, I have to take my baby out to go pee pee, give her some din din, but I'm gonna keep rolling here. See, this is actually supposed to be hash node index of 0. But no. They don't want me to dereference it like this, do they? No. That's not right. That can't be right. So does that have to be a triple pointer then? God damn. I've never actually used a triple pointer. And I doubt very many people ever would. That's right, because every location is potentially its own list of nodes. Real talk, you could technically, do the math right and actually allocate everything as just a single pointer. That is an entity double pointer. Um, now that makes sense. I don't want to go all the way down like that. I just want one. Oh my god, I just want one. Else we will, print some sort of error. This is like a super light hash table. Normally, when you are asked to implement something like this in a computer science class for the first time, you might implement a it's not round robin, but there's a linear probing, right? Like where you if you hash to a location and that location's occupied, then you start checking like the areas around that node. There is that. And then there's also chaining, where if you hash to a location and it's occupied and you're like inserting or you're looking for another node that might exist at that same location, then you might use like a linked list structure at every location in the hash table in order to check, like if you have two nodes that like hash to the same location, the first one that's inserted might end up at the very end, and you just step through it one at a time to see where your object is at. So in this case, we're like limiting this to like a maximum of 3 levels. So if we have like 3 entities that end up hashing to the same value, then we can basically just plug those in. But if we have more than 3 that go to the same location, then we're fucked, and we're not going to do anything. Now, this code is kind of bad. This is like super nested, and we're doing a lot of the same things over and over again, right? So one thing we could do, kind of rewrite this into a loop. So if the item exists at that location, or either if it doesn't exist because it's null, then we can just like drop it right in there and then break. And that's a lot cleaner than what I just did there. But I knew what I wanted to do, and the LLM just kind of took what I meant there and cleaned it up a bit for me. And oftentimes I'll write the innermost part of a loop first. So it's definitely a skill to like be able to spell out the meaning of your code in a way that like you can communicate that to an LLM, which might be able to extend or clean up your current representation. I recently heard that llama.cpp just had a like 98% rewrite done by DeepSeek R1, and apparently it's achieved like a 50% like speed boost on CUDA or something like that. I may be misquoting, or maybe I misread, but That's the idea of self-improvement, man. Like, all right, so at this point, it gets inserted, but we want to like maybe report on did insert did name equals false, did name equals true, and then that way we can say if we didn't assign the name for some reason, then boom. What are we doing next? Good. Now I'm not properly freeing that memory at the very end of the program, so don't cancel or kill me yet. Jesus, I'm aware of the state of my code. And that's why I was saying ideally you avoid having to do any sort of mallocs or freeze. That's why it's a great idea if you can to, get everything onto the stack. So like what if I wanted to do this on the stack instead, right? Name chain size is not right. It should actually be list size first. And then chains. What? Brackets are in what? Oh, after the identifier. Well, that's the fucking LLM's fault, man. I didn't do that. $1986. Good year. Oh yeah. We have to fix this. If so we'll come back to this part. So this isn't right anymore because now we actually have real objects inside the names. Not going to be null though. We're going to set the ID equal to -1 and we're going to zero out the name. Okay. So this will be a little bit better because if entity names hash index of I dot ID equals -1, let's see. So here it's like attempting to do a hard assignment, but it can't do that. But we can copy over. Values. All right, so now it's on the stack, so now we don't have to worry about freeing shit, right? We're not actually calling this function yet, but we're about to. So create hero would call create entity, which entity So we're going to start off with just hero. Because remember, we're doing this component style, like family style. Y'all familiar with that Frank Castle sketch? That shit's funny. Shout outs to that guy. Man, I gotta check out his new content. Big fan of his, big fan of Sam Hyde. Big fan of $1 Million Extreme. It would be pretty gross to do a hard exit here, right? So here at least we can copy over the hero ID. So when we create the hero, or when we ever create any new entity, we insert it into the entity list first. If it's too big, we don't do that. Otherwise, we do it, and then we create a new. We don't need a new name node anymore. We can just copy it directly over. It's kind of nice. Memory safe programming in C. Pro tip. Use the stack. It's there for a reason. In fact, I saw a really good article a long time ago about good C++ programming techniques using that as well. So, coming up here on Din Din time, maybe time for a little breaky poo. Maybe get something in the oven for myself. But before we do that, we want to. Here we actually do this, but we now actually want to call create hero here. Well, the code's not crashing, so that's a good sign. Take this moment to check things in. Of course, stuff that I do today and always will be cleaned up in the future. What's important is being able to get results now. Because if you can get results now, you can always go back and refactor your stuff to make it cleaner. But there is a balance between writing it well and writing it works. We're going to end up doing something similar for handling like positions. probably just have like a raw. Let's create an entity, but we haven't assigned a position yet, right? We pass the name in because you go and just create the name with the entity. And then we have to actually assign values and init the position hash table. We can do that all in the same loop there, which is nice. So I is the hash index, J is the chain position. So when you go to create entity, lib game, here we'll just do a raw set and we'll worry about bounds checking later. See. Okay, so now we have a function for assigning the position. So after create hero calls that thing and does that. Create entity assigned it to the list, and now we know it's in there because we're at this point. So we just loop game assign entity position. Const loop game get entity position x, or we would do POSX. Oops. Okay, there's our two functions there to get the values back, because this is a demo. I'm going to try printing them out in the debug panel, or at least on the command line. Oh, we could actually just go into update debug panel. Get the hero ID like that. The game. What was it called? Oh man. Get entity pause. Hero position is still -1, -1. And it's showing hero ID. Oh yeah, an entity count down here should be darn it. Are we not calling create hero? Yeah, we are. Oh, look, it's being called. Oh, duh. I forgot. I have to turn on. Okay. 1347 I gotta turn off. Get entity position. Oh, yeah, naturally. 2273. $22.53. It says it's been assigned, but I know it hasn't because it's not reflecting up there. I know I said I was going to keep rolling, but I'm going to take a break to eat as well. Take care of my dog, and I'm going to fix this today. This is unacceptable. All right.